So today we have a lecture on loops and variables, and the lecture shouldn't take us too long, I hope. There is this week also a tutorial. The tutorial is flowcharts, and there is a lab which is also flowcharts. So kind of like we've had for a couple weeks now. Flowcharts are the go, but added to that, we're also going to do this idea of tracing. So in today's lesson, we'll introduce the idea of the state of a computer program. So we can measure the states, particularly by looking at the values of our variables. So in today's lecture, we have to look at variables. Otherwise, we wouldn't be able to understand the concept of states the way that we want you to understand it for this course. So we'll be looking at that. I have put links for all of those things there. The lab we'll do in the last lesson this week. So we won't look at that today. And depending on how we go in this lecture, maybe we'll just do the lecture and do the tutorial all in the next lesson. That's probably the way we'll do it. But if you guys feel like you want to press ahead, we can look at the tutorial as well. Certainly you can look at the tutorial going ahead. The other thing I want to say is that we do have a, I do have your test. You can see your test result on D2L because I published that. So you can see that. I also have for you your flow chart. You can look at that. I do want to take it back. So what I recommend you do is I'll hand it out, take a photo of it, then you've got a record of it, and then hand it back to me. I'd appreciate that. So yeah, loops and variables, that's what we want to talk about today. Let's get started. We've already introduced the idea of a loop when we were talking about selection. So I remember one of the slides that we had in a previous lesson, it mentioned that there were three constructs in computing that we use: control structures, sequence, which means that one, depending on the order of the lines of code in a program or an algorithm, that's the way that they are processed. So in other words, the first line of code is processed before the second line of code, which is processed before the third line of code, etc. So it works like that. That's one of the three constructs. The other two are kind of related. Selection, the idea being that based upon some condition, the code can, some lines of code can be processed and some lines of code would not be processed. And we have talked about that at some length in previous lecture. And I introduced you to the idea of the programming construct of if then else. You've seen that, right? If then else. And in the flowchart, we use a diamond structure to represent a decision. And based upon the condition in the diamond box, we would go to either a true, which would go one direction in the flowchart, or a false, which would go another direction. So those are two of those control structures. The third control structure was a loop, which is kind of similar to the select, but the idea being that a whole bunch of commands would be repeated until a particular condition was either true or false, depending on how you set it up. So we have a while structure that we used for that. And there's also a for structure. For structure, I don't think that we'll probably look at that too much in this course. You'll see that in other courses, but if you know a while structure, you know enough to do a for structure, because a for structure is just a while structure written in a condensed way. So for structures are nice. So repetition, we use this word repetition. We use it along with the words iteration, looping. So that's how we often refer to it in our courses. We might talk about a do while loop or a for loop, and that's how we implement it. Now, as mentioned in this slide, the power of the computer, the reason why we use it, computers are not smarter than people. We have to tell the computer what to do, except in the case of artificial intelligence, which still we have to set up the parameters for it to discover the relationships and patterns that it uses to develop its, well, develop its rules. But what the computer can do better than a human is it has speed. So that's what we were talking about. It has speed. It can process millions of commands in a second. So I mean, you talk about your computer processor having gigahertz clock speed. Gigahertz, that's billions of cycles per second. And with the Van Neumann architecture, we learned that it takes like 3-4 cycles to process a command. And so I mean, so if you've got 2.3 billion cycles per second, you can see that you could be doing certainly hundreds of millions of processing commands every second on your computer. And that's a lot faster than we do it. All right. So that's what we use computers for. They're very, very fast. And so we want to repeat things. So for example, if we wanted to process everybody's tax status or something like that in a large country like the United States, you've got, I don't know, maybe 150 million people that are registered taxpayers. And the government there would like to know that people are paying their tax and how that's going. Each person has a unique number, which is their tax file number, and they would all be processed in not too dissimilar a way. Well, computers could do that fairly quickly. It's not going to take them years to find out who's paid their tax and who hasn't. As long as the information is put into the computer systems, certainly the computer systems can pull that kind of information out fairly quickly. All right, so you have actually seen this flow chart. This is a flawed flow chart. This is a flow chart with an error in it. And I think that if you looked at it carefully, you can probably see that what the error is. What we see is an attempted loop, an attempted iteration. So iteration means repeating. So loop, iteration, these words, we use them the same. What's missing from this flow chart? What could we add to it that would remove the error? Can you see? Can you imagine? I know students don't really like to talk in lectures. That's my job, I suppose. So I will go ahead and answer that question, which is sort of rhetorical. But yes, we could put a diamond structure at the point where we have the crossing down here, and the diamond structure would have a condition in it. And depending on where that condition were true or not, we've got a branch. So we could go one way or the other, depending on a condition at this particular point here. So that would be how we implement a loop. So that's kind of like what we did with the if then else, right? If then else is controlled by a condition. Likewise, a while loop is going to be controlled by a condition. So repetition, we use that word to describe what we're doing here: repeating, iterating, or reiterating, or looping. All means the same thing. We have to control that with a control structure there, condition. And we have two different ways that we control it, as is mentioned at the bottom of this slide. We can do that by counting. If we're going to count, what we typically do is we set a counter to 0, then we add 1 to the counter every time we go through the loop. And then when the counter arrives at the number that we have predetermined, then we stop. That's one way of doing it. That's the counted loop. The other way of doing it, it mentions at the bottom of that slide, the very last sentence, the Sentinel loop. And how that works is that we have the user or the system somehow input a value, which is a Sentinel value. So it has a special meaning, I suppose you could say. And when the processing comes across that value, it will stop. And so that's going to be by some user input or something like that. And we use these two different ways of controlling our loops for two different kinds of loops. And basically, it's fairly simple. And I hope you'll remember it by the end of this lecture. But we use a counted loop when we know beforehand how many times we're going to do it. So if I know that, okay, I'm going to do this 100 times, I'm going to use a counted loop, and I'll count up to 100. But if we're going to do something and we don't know how many times, because it'll depend on some circumstances that are, from the user, then we would do a Sentinel loop. So in other words, we'll ask the user to say that they want to stop repeating. Do you want to keep repeating? Yes or no kind of thing. So a counted loop, that's the easiest one to understand, maybe not. It's fairly easy to implement. We start with a counter, we initialize the counter at a low value or a high value, depending on how we want to do it. But usually we start with a low value like 0, and we add 1 to it until we get to our number. When we get to our count, we stop. That's fairly easy. And the example that's given here was the punishment example. Typically in a punishment example, when we used to punish students like that in high schools and primary schools, I suppose, it would be, we're going to have this punishment 100 times or something like that. I will not 100 times, right? Before we start, we know that we're going to do it 100 times. Perfect for a counted loop. And this is that flow chart for that represented here. And so I hope you see the improved flow chart. Improved flow chart. We do have a decision diamond there. And in the decision diamond, it has a condition. The condition is that the number of iterations is 10. Now, this is still a flawed flow chart because we have no way of sort of getting to that point. How do we go from 0 to 10? It just asks the number of iterations is 10. So we have to have some way of starting from a low number and getting to a high number. And that's in the next slide. So we do that there. So before we actually do any printing outside of our loop, we initialize. This is initializing the counter. We use the word initialize. Initialize means the starting value. Initial is the starting. So the starting value is 0. And you see here, just before we do the test condition, just before we have the diamond in our flow chart, we increment. Increment means to add a small amount. So when you start working in your jobs, you'll be looking forward to the end of the year because then you'll get a salary increment, right? Salary increment means that your pay goes up by a little amount, maybe by a big amount, but it'll go up. And every year you get that, right? So that's the same in this program here. Every time we go through the loop, we add a little bit to it. Add 1. And eventually, when it gets to 10, the number of iterations will be 10. And so we won't have to go back to the loop. We get to go out to the end. So that's how that's going to work. So we're using a counter. We have to initialize the counter, and then we have to increment the counter. Increment means add to it. All right, so we could do this with the happy birthday. It asks us, can we draw a flow chart for that? Maybe you can help me with this. Flow chart always starts with a start. It's pretty much the same as what we saw on the screen a minute ago, right? So a happy birthday. In this one, what it's saying is we ask the user for their age. So that's going to be an input, right? We're going to get the age. I'm just going to use get because get, people understand that get means to ask and get it. All right. So this is actually, when we implement this in a computer program, this would create a variable called age. That's what we'd want to do. And then we want to give it a value. The user would provide the value. So that's what I mean by that. So this is an input, right? And we recognize that by this shape, it's an input, yeah, or an output. That shape means input or output. Now, once we've got their age, what's the next thing it says to do? Happy birthday to you, their age number of times. So we have to have a loop. This is a counted loop. It's a counted loop because we know how many times we're going to do it. How many times we're going to do it? As many times as their age. As many times as their age. And so what we're going to do, and we could put the process before or after the condition. I'm going to put it before the condition just for simplicity. But what that's going to be is we're going to print happy birthday. Oh, we're missing something, aren't we? Ooh. We need to do what? I need to, before I print the happy birthday, I need to initialize the counter. But I could do that before getting the age, but it's okay, as long as it's before this. Initialize the counter. initializing the counter would be counter takes the value of, well, let's do it from 1 because it's going to be more intuitive for you. And then what we're going to do is we're going to print happy birthday. Now, hopefully, you'd recognize that would be an output. But at this point, we have to have a decision box, a diamond. And what we're going to do is we're going to put a condition there, which is the age, or is the counter, actually, no, I need to increment the counter. Let's do that. So increment the counter. What that's going to do is the counter is going to take the value of the counter plus 1. Notice I don't say counter is equal to. I'm writing it with an equal sign, but that doesn't mean equal to in the same way that you're used to using equal to, I think. What this is saying is the variable counter is going to have a new value, and the value is going to be equal to what its old value was plus 1. Counter takes the value of counter plus 1. So that's an increment. And then I have to test. And so what I'm going to test is the counter still less than the age. And if it is, sorry, that's a bad looking diamond. That's supposed to be a diamond. All right, supposed to be a diamond. So if it is, then that's a yes. If it's still less than the age, then what we're going to do is we're going to go and print happy birthday again. We keep printing as long as it is. If it isn't, then we're finished. And it's supposed to be oval. So that's a loop with the condition where we have done a counted, but the counter, the actual count target was given to us by the user before, but we knew beforehand how many times we're going to do the loop. The loop is here. But before we get here, we know how many times we're going to do this loop, right? It's going to be as many times as their age. So we get their age, and that's how many times we're going to do the loop. So we're using a counter. We initialize the counter. We added 1. Actually, this should be less than or equal to, because we started counting from 1. And that will get us our loop. We'll come back and look at that with Python later.
Why we added 1?
Why we add 1?
Yeah.
Well, it's a counter. I mean, so the 1 is for how many times did we say happy birthday? And so for every year of their age, we're going to say happy birthday. And so, you know, for when they were 1-year-old, for when they were 2-year-old, for when they were 3-year-old, up until they are as old as they are now. That's how many times we're going to say happy birthday. So for every year we add 1, just like you do, right? When you have your birthday party, you know, yesterday you were 19, now you're 20, like that, right? We add 1, correct? Yeah. So do you want to look at the Python now on that, or look at it later? Later? Yeah. All right. So let's continue with this one. Now the Sentinel loop, the idea of the Sentinel loop, we're still going to have the condition at the end of the loop, but the user is going to say go or stop. The user is going to start the loop. Now we use this before we start the program, before we start the loop, we don't know how many times we're going to do it. The user is in control of the loop. So it gives an example there of a sales program. So supposing you had a program, where the user enters an amount, how much was sold today. And this loop will, that's bad, isn't it? Without the decision, let's put the decision book in there. So this loop will keep on going. We'll keep on going, but we've set a Sentinel value there. We set a Sentinel value of 0. And that would be typical because it's outside the range of what normally a person would put. You wouldn't usually have a sale of 0, right? So we know that the user is not going to probably put a sale of 0. So what we're saying is, we know that you aren't going to have a sale of 0, but you can use the sale value of 0 and that will stop our program. That's a way of stopping our program. So it's not really all that elegant way, of stopping a loop, but it works. All right. Now, that means that you have to be careful, because if we put a number in here that was actually a possible number for our sales, then you would mess up your program possibly. So we typically choose a number for our Sentinel that somebody wouldn't normally use. Often we'll just say if it's a number less than 0, because nobody's going to enter a negative number for a sale. All right, so when the user types that the sale is 0, then we're going to stop our loop. But any other number than 0, and then it will keep. You know, if it's not 0, then it will go back and ask for another amount. It'll add that to the total. If it's not 0, keep on doing that. Eventually, when the person types 0, then it exits the loop and does whatever processing is later. So typically, as said there, we need to choose a Sentinel value that people aren't going to use in their normal, in their normal programming. So in this case here, it's recommending a number which is a negative number. Now, if you put a negative number there for your sales or -10, you'd want to make sure that that wasn't added to the total, right? Because that would mess up your totals. And so you have to be careful where you put your Sentinel. Put your Sentinel at the very end of the loop, so that any value that's there isn't added to the to any totals or any calculations. So that it is kind of tricky using a Sentinel value. All right, let's do another one here. I will not cheat on my assignments, and the user gets to say when they will stop. So I'm going to put that one up here. The user gets to say when they will stop. So we could start. We can do an output, which would be a print. I will not cheat. So we're going to do it once. And then we're going to ask the user if they want to keep going, right? So, so we can say, we're going to get a user input. Get, again, what does it say? They can either say again or stop. Get again or stop. So if it's again, which is yes, basically, then what we're going to do is we're going to go and print this again. Now notice we haven't got a counter in here. No count. No count equals 0 or count equals 1. All we do is this is what's controlling it, is that the user is going to input. Oh my goodness, I'm sorry. The get is an input. It's not a decision. I'm so sorry. This, please ignore the shape there. This is a get statement. So that should be another one of those. This is an output. This is an input. Then we do our decision. Sorry. So our decision is going to be, is it again? And if it's again, then we go and print that and we ask them. And if it's not, then we end or finish. So I hope that didn't confuse you, because I missed out this step, but I put it back in there when I realized what I said. Can you please put the doorstop in?
Is it okay to start with output?
Sorry?
You can start with output.
Oh my gosh. Yeah, that's fine. We could start with the output in this one. Yeah, as long as the output is in the loop. And so I put it in the loop there. I put it at the start of the loop. That one will work quite well. We'll test it in Python at the end of the program. So the point that's here is question: when do we use a counted loop? When do we use a Sentinel loop? We use a counted loop when, I've already said this a couple of times, so do you remember me saying it? Before we go into the loop, we know how many times we're going to do it. Then we just count up until that many times. Before we go into the loop, we know how many times we're going to do it. That's a counted loop. The Sentinel loop is, we don't know how many times we're going to do it. The user is going to just say stop, and then we'll stop doing it. No, it's not. We don't, I don't know, the magnets work better, right? So the Sentinel value, we don't know how many times we're going to do it until we actually get in the program. Then something, some magic number. I guess you can think of the Sentinel as like a magic number that or it doesn't have to be a number. Here, it's not a number. It's again, again. Are you going to do it again? All right. So that's the first topic of today's lecture. Today's lecture has kind of got two topics. And so the second topic is this idea of states. What's going on inside the computer and in the program. And we'll talk about tracing, I suppose, a little bit. And in order to do that, we need to understand how the memory works and how a variable works and a constant and what these things are. So hopefully you remember from first or second lecture, we did talk about this a little bit, that the way the computer is constructed with the Van Neumann architecture, you have some memory, right? And in that memory, each memory position has an address. So the memory can be addressed by the computer operating system program. We can go and say, at this place in the memory, there's something there. So what we do is so that we, as people who are not computers, can communicate with the computer through the programs that we have, through the operating system and the computer programs, we will say that I want to put something in that memory and I want to come back and use it again later for something else. Well, what that something is going to be a variable or a constant. So our variable or a constant is going to be something in the memory, which we give a name to, and then when we put a value in there, or the computer program does, and then later it can come back and use that value or change that value. And by doing that, the state of the computer through its variables will change. So how that is discussed in this slide, we notice that these memory addresses in the memory, they have an index on them, and they only store binary number values. So we have to take everything that we're doing and convert it and translate it into binary numbers. Now your computer program does that one line at a time. If you've got an interpreter, or if you're using a compiler, it takes the whole program and creates a file, and that's all in binary code. But then also our values in our inputs, they have to be converted to binary numbers as well. Anyways, that's a lot of stuff to say in one slide. All you need to know is that we are able to control some of the memory through our computer program by assigning a variable name or a constant to it, and then storing something in there. And once it's stored in there, we do have an index on it, so we can get it back out. And we can change it. So we have variables and we have constants. So for example, in a program, you could use a variable to control, we can see what's in the variable. The variable could be used to control the loop. So for example, the counter here is a variable. It's called a variable because it actually changes its value during the program. So the counter started out as 1, it'll become 2, 3, 4 as it goes through the program. And eventually, yeah. Counter, as we say, the variable or the constant is an alias, because there's an index in the memory which says what that memory position is. That index is then going to be related to the variable name that we set. We create a name in our program, and that is how we access the index for that memory. All right, so we use constants and variables differently. The constant is going to be a value that's not going to change during the computer program. The example given here is we might use a mathematical constant like pi. And so pi never changes. So if we're going to use pi in a program, we would probably set it as a constant. We don't want the computer memory to change that value during the program. So that would be a constant. There's other things that we would put in constants as well. As it says there, if we were calculating a circle, anything to do with the circle, the pi would be a constant. But if we had different circles that we wanted to process, we would use radius as a variable. So depending on what radius we entered into a computer program, we could get a different area or circumference for the circle. And that's what that slide is talking about. This slide is just talking about our presentation in our computer programs and our algorithms. When we use a variable, we tend to use lowercase letters to describe as the name for the variable. And if the variable is made up of more than one name, two names together, like what we've got here, student name. The name of our variable is student name. Because you might have a program where you have lots of names that you're storing in your computer program. And maybe you've got the names of teachers, and maybe you've got the names of students, but you want them to be treated differently. So you might use student name and teacher name as different variables. Does that make sense? Now, so that's a big name. We tend to use big names because they're meaningful. You know what I'm saying? This, we don't have to use student name. We could just use S and the program would work perfectly, but it might be hard for us to read it. And so, I mean, the reason why we have this is for us. So it's easy for us to read the program and know what's going on. We know that that is a student name, all right? As I said, we could just put S. The computer will work perfectly with S, but it might be hard for us to read the program and to fix it if there's any errors. So do you notice what's happening with this variable name, student name? There's a capital for the N. This is the variable name, we use lowercase, but if there's more than one name, more than one word in the name, the second, third, fourth will all be capitalized. Not the whole word, just the first letter. And that's, we actually call that camel case. I guess we call it camel case because like a camel's got a hump in the middle. I think that's why, right? Now, as opposed to a constant, with constants, we tend to make everything uppercase. And if we're joining two words together, we join them with an underscore. We don't really use numbers for variables, and we don't start a variable with a number. We could use a number at the end of some letters. And the other thing that we don't do is we don't put spaces in the middle of a variable name. Okay, so this slide is referring to the fact that we've got different types of data. So the types refer to, well, what type of data could it hold? These are some of the types, they're not all. There's other types of data as well. Integers, whole numbers, negative and positive, but they're whole numbers like that. So you can see that there's some negative numbers as well. Floating point. The thing about floating point is you do have decimal values. So, and they can also be positive or negative. Characters. Now characters, we've got a character there, 9. That's really just to show things, right? It's not going to be available for calculations like mathematics. So why would we do that? Why would we use number but put it in quotes so that it doesn't act like a number? You know, there's some numbers that we don't want to do math on. So for example, like a student number, that's just a special ID. Your cutter ID number, right? We don't want people multiplying their numbers and divide, you know, I mean, that would really lead them to be confused. That's not what the purpose of that number is, right? Purpose of that number is to identify an individual in a special way. Now, those numbers have special meanings. I mean, you'd know that if you looked at your cutter ID or even your student number, you know, they're in a particular order. We can use numbers at the end of a variable name, but we don't use them at the start. And okay, I think that's enough on that. Now we can display a variable with a print, but yeah, let's just talk about that. What would happen here? We're saying, what if A was 2 and B was 3? And we had this thing here which said C equals A plus B. Be very careful. I'm trying to make you understand here. We don't actually look at this and read it as meaning C is equal to A plus B. What we mean when we read this is C takes the value of A plus B, where A, B, and C are all variables. Okay, so they're memory positions in the memory and they have some value. We have assigned some value to them. Now, what it's saying here is that we assign the value of 2 to A. Where's my cursor? Oh, there you go. We've assigned the value of 2 to A, and we've assigned the value of 3 to B. So C would become A plus B, which is 2 plus 3, which would be 5. It kind of looks like A is equal to, but it's kind of different because we could have said C is equal to C plus B. And you know, mathematically, that's not possible, right? But in a computer program, it's quite possible. You can say C is equal to C plus B. Have you ever seen anything like that in your math? No, you haven't. I'm pretty sure you haven't, right? But C can, in this case, C is A plus B. We could print out C, and it would print out the value 5. I hope that makes sense. So the program state, at any point in time, we'd like to know what is stored in a particular variable. Now, easy way to do that, there's easy ways to do that. Your program has some tools that allow you to do that, to dump the state. If you're just sort of working on it yourself and you don't want to do any fancy tools, you can just put a print statement. Print statement will tell you the value of any variable at that time. I tend to do that. All right, let's do this. A flow chart, happy birthday. Didn't we do that? Oh, the idea is to trace it. So what I'm going to do to make this sort of easier for me is I'm going to write the program in Python. I think it's good for you to see Python. It's not time for you to use it yet, but you will. So I'm going to write the program in Python. And then what we're going to do is we're going to check the state of the variable as we go. So this is going to be the happy birthday program. I don't know if I've done this with you before, maybe. Happy birthday program. We ask the person for their age. So this is the input. Get age. Age takes the value of an integer value. And we do that by asking the user to input their age. And so this is how we do that in Python. We just ask them, this is just a string. And what will happen is they'll be prompted with this string, the stuff that's in green, that will come on the screen. And then they'll type something, and that value will be stored in the variable called age. So this creates a variable called age and stores in it whatever the user types. So the next thing I got to do here is initialize the counter. So counter, this just creates a variable called counter, and it sets its initial value to 1. So I've done that. And then I'm going to print happy birthday. Well, because this is going to be looping, I'm going to put it into a while loop. So while counter is less than or equal to age, I'm going to print happy birthday. Now that won't work because that's going to look for a variable called happy birthday. So I have to put it as a string. And then I have to increment the counter. So counter takes the value of counter plus 1. So this will, let's try this and see. All right, so let's take a small age so it's easy to see, right? So let's take an age of 6, and it says happy birthday 6 times, and just as fast as that, right? So we're seeing the power of the computer because it can do it that fast. And let's see, right? Let's run it again. You might not be too impressed by it doing 6 times, but what if the person was really old 1,000 times? Then doesn't actually take it long to type to do happy birthday 1,000 times, right? So, I mean, that is the power of the computer. So the thing is, you look at that and you say, oh yeah, whatever. But what happened to the counter? So if you want to see what's happened to the age and what's happened to the counter, you can just print them. That's an easy way of doing it, I suppose. So what I'm going to do is I'm going to put a print statement in here, and there I'm going to print, and I'll call this the state of the variables. And so the first one is going to be the age. Oh. And I'll just put the age there. So I'm just going to print the age there. Then I'm going to print the counter. And so what I'm doing here is I'm just going to, this is like a trace, but it's the lazy man's way of doing a trace. So let's say the age is 6. And so we see what happens. The age doesn't change. Now, it's not to say that age is a constant. It's not. It's just that at the start of the program, still a variable, but at the start of the program, the age got changed here and it never got changed again, right? But the counter did change. Actually, now the first time the counter was printed was when the counter got to 2. So why is that? That's because the only time that we printed the counter was after we've already incremented it, right? Started out 1 here, then we added 1 to it, then we printed it. So that's why it's not, if we wanted to see it here, we'd have to put in some more print statements. Yes. Okay. So that's why that is, right? But it still works, right? It's doing it exactly 6 times, right? But so why does it say 7 here? Well, the counter, the while loop is going to keep going until we get to be 6. So it will print this 6 times. When it becomes 7, when this counter became 7, it will stop the loop. If it was 6, it'll still go into the loop. When it becomes 7, stop. Because 6 is less than or equal to 6, right? But 7 is not. Now, if I change this to less than, it'll only print it 5 times, but well, let's close this so you can see it. I'll kill it and do it again. If I change that to less than age, and it'll stop at 6, but it only prints it out 5 times, right? Because we started from 1. Anyway, so you see what's happening to the variable as we go? Now, that's kind of messy. And so what you typically do is say, okay, so I know what's going on with the variables now. I don't need this. I can comment it out by putting a hash in front of it. I can comment it out, and then I can have my program running the way I wanted it to run. Just says happy birthday 6 times. And so all that other information that was just for me for testing the program, you know, it's not messing up the program. So I commented it out. All right, so that's that one. Let's do this other one over there on the left for you guys, which is I will not cheat, right? Okay, so let's do a new one. This won't take too long. I'm just going to call this not cheat. This is the not cheat program. And we're going to do this at least once. All right, so before I go into the loop, I'm going to print it once, apparently. So, all right, so we're going to do a print. And we could say, I will not. Fine. And so do we want to do this again? So we're going to ask the user. So we're going to ask the user, do they want to do this again? So this is going to be an input, and we'll call this again. Oh, no, that's to, let's say, continue. No, that's actually a reserved word. Go. That's not a reserved word. Okay, so here we're going to do an input, and we're going to ask the user, do they want to continue? So again, or I'm just going to say again. So that's just a question. And how they'll answer it is they'll either say again or not. Now, the thing is, this is a really bad way of doing this. but I'm just doing it the way that the program was set up. So what I'm going to do is I'm going to say while. Now, why I say it's a really bad way of doing it, because, you know, what if they typed again with uppercase? What if they typed it with, you know, a mixture of upper and lowercase? We could fix that. We could fix that quite easily, but I don't want to do it here because we'll take too much time. So while while go is equal to again, and it must be equal to the string again, then we're just going to do all this again. What we'll do is we'll print it and we'll ask them again. So we keep asking them, do you want to do it again? Now let's run that and see. It was called cheat, wasn't it? But, you know, again, I got a bad syntax. Oh, okay, that's very good. So this is a teaching moment for us. There's a difference between assigning a value to a variable and testing equality. What I need to do in the condition is I test equality, and I do that with double equals. I know it's kind of weird, but that's how we do it. We don't actually say equal because that would be an assignment. We've used equal before, right? We used it here. That's assigning. So we're not going to assign go another value. What we're going to do is we're going to test it to see if it's equal to again. Let's run it again. So maybe the syntax is going to work this time. I will not cheat again. So if I type again and I get it the way that the program says, can you see it at the bottom? I will not cheat. Okay, so I'm going to run out of room in this. So let's do it again. Let's run it. Okay, I will not cheat again. As long as I type again, it will keep on saying I will not cheat. As soon as I type anything else, it'll stop. I don't actually have to type done or anything. If I just type anything else, it stops. Why? Because it's looking to see if the variable is again. If the variable is not, then it stops. So that's this. Oh, sorry, it's the wrong program. Where's that program? That's the happy birthday program. Got too many windows open. So let me make this window a bit smaller. And there's our output window. There's our program window. Okay, so there's the two programs that we played around with in Python. Got our happy birthday program. There's a while loop there. Two different types of loop. The counted loop. What we had to do is we had to initialize the counter, then increment the counter inside the loop. And then the while loop, the condition is testing on the counter. The other kind of loop is a Sentinel loop. Before we went into the loop here, we got the Sentinel value by asking the user, and we keep asking the user inside the loop if they want to change that Sentinel value. And as long as the Sentinel value is the value that we want, we'll stay in the loop. As soon as we're not the value that we want, we get out of the loop. Does that make sense? All right, so we've done a few things in that lesson. I'm going to stop now. There is a tutorial, but I'm just going to let you look at the tutorial, I think. So have a look at the tutorial. We'll do that in the next lesson. We'll look at the tutorial properly in the next lesson. Then we have a lab at the end. So when I say look at the tutorial, hold on. What I mean is, if you go here, there's a tutorial. It's kind of a long one. Have a look at that. We'll discuss it in class. And there's a flow chart. That's an example. Then it asks you, and there's a tracing. What happens to the variable at each step? And then there's some questions where you have to draw some flow charts and do the outputs. I just thought of something, you know. What I didn't do in the program is I didn't put what was the line number. So, I mean, you probably should do that. Now, if I put a hash here I can put the line number, right? So this is line 1, because what the hash does is that everything after the hash is not used by the computer. That's only for us. So there's line 2. Okay, so when I print this, this is line 4, right? So the reason why I'm doing this is for when I do the tracing, I can see which line I'm on. So in the print, I'm going to print that I'm on line 4. You'd agree that this is line 4, right? See line 1, line 2, line 3, line 4. This is line 5. And so this one is going to be, what's the magic number here? Where are we in the program? Line 6, right? So when we print, maybe we should print the line number as well. Okay, I don't need to, it's not a variable. I'm just going to say line 6. I think this is worthwhile doing because when you do it, run that again. Oh, let's run it so that you can see it. So what I'm doing now is I put the line number in each one. And when I do the print, you can see the line number. I think it's better for the tracing. So let's just have a look. So when I put the age, the person is 12 this time. And so we can see what's happening is the only printing that we're doing is line 4 and line 6, but it's printing over and over again. Line 4, then line 6, line 4, then line 6, line 4, then line 6, line 4, then line 6. So I hope that you can see that it is in fact doing the loop, right? Over and over again, line 4, then line 6. If I put another print statements up here, I would get some other prints. Or maybe I should do that, right? So I could do a print here and say, this is going to, so here I'm going to print its line. This is going to be line 2. Well, because it can't be line 3 because line 3 is already down here, right? So we're going to say this is line 2, and we're going to have the age. And the counter. So if I run that now, let's close this. Run it again. So I hope you can see this. Look, line 2 only happens once. At line 2, the age is 12 as the counter is 1. And then counter becomes 2, then it becomes 3, then it becomes 4, right? We're printing line 4, line 6, line 4, line 6, line 4, line 6. Each time the counter is increased until the counter becomes 12, and then it stops because the age is 12. Right? So I hope you can see that that's how it worked, right? Isn't that cool? So our print statements can actually tell us a lot about the state of the program. What's happening with the variable at what point. I know you're getting tired of me doing this, so I'm going to stop. Now you don't have to do the Python if you feel you want to and have fun with it. I think programming is fun, so maybe you'd like to do that. I'm certainly not telling you not to. I'm just telling you that you don't have to yet. You will have to later in the course. Okay, but not right now. Aren't you happy about that? Come on, end.